hypergeometric distribution has three parameters, n and capital K. So n is the number of population of the entire people in the village. K will be the number of people who remember your brand. And then n is the sample size that you pick. And then your random variable x will be number of people or number of yes or wins among the sample size n that you bring in. Okay, so let's go with our previous example that I just said. Okay, so let's say there are 200 villagers in your village, and then you know that, let's say 50 people know your brand. If that's correct, what's the probability that if you take 10 samples, 10 people, you randomly call 10 people, and what's the probability that you get x equals to exactly 3? That's the question. Okay. Yes?
What did you say K was?
K is like, so n and K is like the configuration of the entire population. Okay. If this is hard, let's say something like this. There are 200 coins, quarters, for example, inside a jar. Okay? And you know that 50 of them are those precious valued silver coins. You know that, right? Coins minted before or 1950 or something, they're very expensive because they're made of silver, not regular metal. So 50 of them are silver coins. And then you take some random 10 coins out from there. Like you may have to just shake it until it's well mixed. And then you draw 10 coins from it. And now the question is, what's the probability that out of the 10, exactly 3 of them are silver? Something like that. Okay. That's the kind of question the hypergeometric distribution would ask. Okay? So it's very similar to the binomial distribution, but it has the awareness that once you take something out in a small population, the very act of taking something out is going to affect your probability. If the population is very big, then it wouldn't change. Or another way to say it is like, this is the case where you have sampling without replacement. Sampling without replacement. And Bernoulli or Bernoulli trial or binomial distribution would be a case where you sample with replacement. So what I mean is like when you sample 10, what you do is you take a random coin, figure out if it's a silver or not, and you put it back and then shake again. Okay? If you do that, then the configuration never changes, so it becomes a Bernoulli trial, because every time you do the trial, the environment doesn't, the setting doesn't change. You're doing everything under the same condition over and over again. Okay. Is that okay so far? All right. So how do we actually calculate this? Well, let's see. What you have to do is you have to think about all the possible ways you can pick 10 out of 200. What is that? How do you count that? Taking 10 coins out of 200. How many different ways can you take 10 coins out of 200?
200.
200.
Choose 10.
Choose 10. This is the sample space. This is like all the different ways you can choose 10. Now, what's the probability? What are the ways you can get? See, if x is 3, that means 3 of them are picked out of the 50 because these are the silver, and then 10 minus 3, which is 7, right? 7 is out of. 7 is picked out of how many?
10.
No, 7 is picked out of. To get the 10, where 3 is silver and 7 is not silver, right? Yes, 7 should be out of 150. Yes. Okay. So you just multiply these two possibilities, and that gives you the ways you can get exactly this. So those will be 50 choose 3, and then 150 choose 7. So that's how you get the probability. Now, if you follow this logic, you can actually figure out easily what happens in general. So if in general you're given nk, lowercase n, and also lowercase k, then the probability, this one will have the probability distribution function p of x equals to k equals to, well, you're choosing small n out of the big N, but out of the k you have to choose small k, and out of the other pool, which is n minus k, you have to pick the n minus k. So that's the formula for the hypergeometry.